Okay, welcome to another physics class. I'm still your physics teacher, Mr. Moses. Welcome to class. In the last class, we talked about linear momentum and how the product of mass and velocity is momentum, and that's how every object in motion that has a particular velocity and mass has momentum. In this class, we'll be talking about elastic collision, which is still under linear momentum. Elastic collision has to do with the collision of two or more bodies where the total momentum before collision is equal to the total momentum after collision. Now, in elastic collision, the total kinetic energy before the two objects collide is equal to the total kinetic energy after the two objects collide. So even as momentum remains the same after collision, the kinetic energy of the two bodies also remains the same. That is to say that when two objects, like the example you see above, two balls collide with each other, they bounce off each other. In elastic collision, the objects bounce off each other with different velocities, but the total kinetic energy before they collided is equal to the total kinetic energy after they collided. But physically, when they collide, they bounce off each other. Hence, we have the formula m1u1 plus m2u2 equal to m1v1 plus m2v2. Now, this shows that momentum is the same and kinetic energy is also the same for elastic collision. And then we have inelastic collision. For inelastic collision, the momentum is also still the same before and after collision. The total momentum remains the same, but the difference between inelastic and elastic collision has to do with the loss in kinetic energy. Remember, we said that for elastic collision, the kinetic energy before collision is the same thing as the kinetic energy after collision. But for inelastic collision, there is a loss in kinetic energy. There is a drop in kinetic energy. And when the two objects collide, for elastic collision, after they collide, they bounce off each other. But for inelastic collision, when they collide, they stick together and move with a common velocity. In elastic collision, we said when they bounce off each other, they move with different velocities. But for inelastic collision, after they collide, they move together with the same velocity. Hence, you can see in the diagram. So that brings us to the formula m1u1 equal to m2u2 equal to m1 plus m2 bracket v. The reason why we have only one velocity after collision is because the two objects, when they collide, they stick together and move with a common velocity. The reason for sticking together is because there is a loss in kinetic energy. There is a loss in kinetic energy. And then we'll now go to the formulas above. As you can see, for elastic collision, momentum is conserved, kinetic energy is conserved. After collision, the two objects have different velocities. As you can see in the formula above, the formula on top shows conservation of momentum and the one below shows conservation of kinetic energy. While for inelastic collision, the momentum is conserved, but there is always a loss in kinetic energy. The two objects move with a common velocity. Hence, after the equal sign in the second equation, we have half m1 plus m2 times v square. which is their common velocity. And then we go to conservation of momentum. As we have been saying before, this is letting us know that as far as collision is concerned, momentum is not lost. It is only energy that drops. Momentum is never lost when objects collide. The collision before the momentum before the collision is always equal to the momentum after the collision, like the example above. The second car, the red car, is moving with a faster speed than the other car, but after the collision, the other car moves with a faster speed than the red car. Velocities changed, but the momentum remained the same. Try out the leading questions in your notes. I'll visit them in class. That will be the end of our lesson today. Thank you very much.